Let's start with a confession. Have you ever done something for the first time? Maybe you baked a loaf of sourdough or wrote a short story or, coded a simple app, and it actually worked.
Oh, yeah.
It wasn't perfect, but it was clean, it functioned, and you felt like a genius.
That's the beginner's luck phase. It's a great feeling.
It is, but then you decide to do it again. And because you're riding that high from the first success, you tell yourself, okay, this time I'm going to do everything I couldn't do the first time.
I'm adding all the features.
All the features, the walnuts, the raisins, the complex braiding pattern. And what happens?
You end up with a burnt, unrecognizable brick.
Right.
In the kitchen, that's just a failed dinner.
Right.
But in software engineering, that is a career-defining catastrophe. And it's so common that Fred Brooks actually gave it a name, the second system effect.
And that is the absolute centerpiece of today's deep dive. We are digging into the Class 8 notes for CS326 Software Engineering for the spring 2026 semester.
And we have a fascinating stack today.
We really do, because we're looking at two absolute titans of computer science literature. We've got Chapter 5 of The Mythical Man Month by Brooks, and we're pairing it with Chapter 3 of The Pragmatic Programmer.
And it is such a deliberate pairing. You have Brooks giving us this high-level, almost psychological warning about arrogance and over-engineering. And then you have the pragmatic programmer coming in with the basic tools, the tactical on-the-ground habits you need to actually survive.
Yeah, and plus we have the specific marching orders for the discussion leaders and some very tight deadlines for Bugzilla and Lab 2 that we need to get to.
Oh, yeah, definitely.
But I want to stick with the second system effect for a moment, because the reading notes describe this arc. This arc of a software architect that feels almost Shakespearean. It's like a tragedy in 3 acts.
It really is. And it starts with the first system.
Which is usually a success, right? But the notes imply it's successful for a very specific reason. It's not because the architect is a genius.
No, not at all. It's because they're terrified.
Terrified.
Right. Yeah. Exactly. Picture a junior architect. They're fresh, they don't know everything, and they're working under strict constraints, time, budget, whatever.
So what do?
They play it safe. They ruthlessly cut features. They keep the design, sparse and clean. They're just clearing the deck because they're afraid the ship might sink.
And because they kept it simple, the thing actually ships. It works.
And this creates the perfect track record of one.
And that's where the trap snaps shut.
That's it. Confidence just spikes. They look back at that first system, and they don't see the success of simplicity. They see all the frills they had to cut.
All the cool ideas they had to leave on the whiteboard.
So when the boss comes in and says, ready for the second system?
They say, absolutely. And this time I'm putting everything in.
Every bell, every whistle, every single embellishment. The architect tries to incorporate all the ideas from the first system, plus all the new ideas they've had since.
And the result
is this bloated, heavy, slow, over-engineered mess. Brooks calls the second system the most dangerous system a man ever designs.
It's interesting. The notes use this really vivid metaphor of the dinosaur effect. They talk about the last and finest of the dinosaurs. And I read that and I thought, wait, is the technology itself old? Or is it the mindset?
Well, it's a bit of both, but it's primarily about refining a dead end. The notes describe this tendency to settle on a technique and just polish it to perfection, right at the moment that technique is becoming obsolete.
Like building the world's most perfect steam engine the year the diesel engine is invented.
Precisely. Or in computing. Imagine spending years optimizing a system based on, vacuum tubes.
Yeah.
Making it the absolute finest version of that tech, right as the silicon transistor takes over.
Right.
The second system architect is often so focused on the how, making it fancy, that they miss the what, the fact that the hardware landscape has changed under them. They are building a beautiful dinosaur.
That dynamic, the how and the what, brings up the social aspect, which I found really spicy. The notes talk about the relationship between the architect and the developer. It sounds like a power struggle.
It is a delicate dance. The architect is responsible for the design, the what. The developer handles the implementation, the how.
And the second system effect just destroys this relationship.
It does, because the arrogant architect starts trying to dictate the how. They start micromanaging.
Right.
And here's the classic scenario from the notes. The architect designs something huge. The developer looks at it and says, this is going to cost a fortune in memory and time.
And the architect, with that second system ego, just doubles down.
Usually. But the notes say a good architect has to handle this differently. They have to do an ego check.
They can't just command the work to be done faster.
No. They have to either cut the scope, admit they asked for too much, or, and this is the key skill, they have to suggest cheaper alternatives.
And that word suggest is so important. It says they should suggest, not dictate, and do it quietly, privately.
Right, and never ever take credit for the developer's solution. If the developer finds a way to make it work, the architect just stands back. It's about maintaining respect.
Lose the developer's respect, and your system is dead anyway.
Pretty much.
So if this second system effect is almost inevitable, if human nature pushes us to be cocky the second time, how do we stop it? What's the defense?
Well, there's the analytical defense.
Yeah.
You have to measure the value of every feature.
Yeah.
Does this actually justify its cost?
Okay.
But the structural defense is more interesting. The notes suggest you need a specific type of oversight. You need a senior architect.
But not just any senior person. The notes are specific. You need someone who has built at least 2 systems.
Exactly. You need someone who has already survived their own second system failure. Someone with scars. They could look at your design and say, I know you think that complex feature is brilliant, but I tried that 5 years ago and it tanked the project. Cut it.
You need that voice of experience to puncture the balloon of confidence.
It's like you need a sponsor at a recovery program. Hi, I'm Dave, and I once over-engineered a database.
I'm Dave, and I built a dinosaur. Okay, so that's the strategic danger. We're avoiding the bloated mess. Now let's pivot to the pragmatic programmer section, which feels like the toolkit you need to actually build that clean first system. The chapter is called Basic Tools, and it starts with a philosophy. Tools amplify your talent.
I love that. Think of it like a craftsman. You could be a talented woodworker, but if you're using a dull saw and a bent hammer, your furniture is going to look terrible.
Sure.
In software, our tools are things like file formats, shells, and editors. And the first one they highlight is surprisingly simple: plain text.
This one always trips people up, right?
Yeah.
It seems so low-tech. We live in a world of complex databases, proprietary file formats. Why are the notes arguing that plain text is a power tool?
It comes down to 2 things: longevity and transparency. The notes call plain text self-describing.
Meaning I don't need a special decoder ring to read it.
Right. Let's look at the alternative. If you save your data in some complex binary format like an old word processor file from the 90s, you're betting that the software to read that file will exist in 20 years.
And if that company goes under,
Your data is locked in a black box. It's effectively gone.
whereas a text file from 1970 is still just a text file. I can open it in Notepad, I can open it in VS Code, I can read it with my eyes.
Exactly. It's insurance against obsolescence. Now, there's a trade-off, and the notes are honest about this. Text takes up more disk space than a compressed binary file, and it takes more CPU to parse it.
And in the 80s, that mattered. But today...
Today, storage is cheap. Engineering time is expensive. The notes argue that the insurance of having human-readable data is worth the cost of a few extra megabytes. Plus, it allows for interoperability. Everyone speaks the same language.
That leads perfectly into the next tool, the shell. This section had my favorite acronym of the entire stack. We all know YSIWG, what you see is what you get.
Right. The promise of every graphical user interface.
But the notes just slam this. They call GIA YSIASHI.
What you see is all you get. It is a scathing critique.
Okay, break that down. Why is all you get a bad thing?
Because a GUI is a limited menu. If the designer put a button there, you can click it. If they didn't, you can't. You are confined to the imagination of the person who built the tool. You're in a cage.
And the shell is the key out of the cage?
The command line is a language. It lets you compose tools. You can take the output of one program and pipe it into another program that filters it, and then pipe that into another program that renames them. You can build pipelines the original creators never even thought of.
It's the difference between ordering off a menu and
being able to actually cook in the kitchen. Yeah, that's a great analogy.
Yeah.
The notes warn that if you stick to the GO, you'll always be a user. To be an engineer, you have to be comfortable in the shell.
Speaking of being comfortable, let's talk about editors. The reading is intense on this. It says your editor shouldn't add friction.
Yeah.
It sounds like they want you to reach a state of flow where you forget the editor even exists.
They do. They talk about editor fluency. The idea is that the speed of your typing shouldn't be the bottleneck for your thinking. If you have to stop and think, wait, where's the menu option for find and replace? Then you've broken your train of thought.
So this is the justification for everyone who is obsessed with keyboard shortcuts.
It is. The notes say explicitly, your choice of editor sets the limit on your productivity. If you're using Notepad, you have a very low ceiling. You need to master a power editor so that manipulating text becomes muscle memory.
Okay, moving on to what the notes call the giant undo button, source code control systems, or SCCS.
Or, as most students know it, Git. But the principle is much older than Git.
I feel like students often skip this if they're working alone. They think, I'm the only one on the code. Why do I need version control?
And that is a fatal mistake. The notes are so emphatic, even a one-person team should use version control.
Why, though?
Because you aren't the same person on Friday that you were on Monday. You forget why you made changes. You introduce bugs. SCCS is a time machine. It lets you go back to yesterday when everything was working. It lets you see the exact lines that changed.
Those who cannot remember the past are condemned to repeat it.
Exactly that. Without version control, you're condemned to refix the same bugs over and over. It's the foundation of a professional workflow. You can't be a professional engineer without it.
Which brings us to the activity that takes up, 50% of our lives? Debugging. The notes have a section on the psychology of debugging that I think every student needs to tape to their monitor.
It really is a psychological battle. The first thing it tackles is denial.
That's impossible.
We've all said it. I wrote the code, the logic is sound, it is impossible that it's crashing.
Yeah.
The notes are brutal here, they say. Clearly, it isn't impossible because it happened. You have to switch your mindset from defending your ego to solving the puzzle.
It says don't treat a bug like an accusation. Treat it like a fact. And once you accept that, you have to find the root cause, not just patch the symptom.
Right. Don't just put a try-catch block around the crash to silence it. Find out why the data is corrupt in the first place. And to do that, they recommend the rubber duck method.
I love that this is official curriculum. Explain the rubber duck.
It's simple. You explain your code line by line, out loud, to a helpless, inanimate object. A rubber duck, a coffee mug.
A plant.
A plant, whatever. And why does this work? Is it magic?
It feels like it sometimes.
It's cognitive processing. When you read code silently, your brain just skips over gaps. It assumes you know what it does. But when you have to speak it, here I am iterating through the array, you force your brain to slow down and verify the logic.
And you catch yourself.
You'll say, and then I check if X is greater than. Wait a minute. You solve the problem just by verbalizing it.
The notes also mention a more technical technique, the binary chop.
Divide and conquer. If you have a massive data set causing a crash, cut it in half. Feed half to the program. Does it crash?
No.
Then the bug is in the other half.
Yeah.
Cut that half and just keep going. It's the fastest way to isolate a problem.
And finally, the junior mistake warning. Don't assume.
It must be the compiler. It must be the OS. Linux is broken.
I've definitely blamed the compiler before.
We all have. And we were all wrong. The notes remind us it's almost never the OS. It's almost never the compiler. It is your code. Verify everything. Check your assumptions. And please, for the love of all that is holy, fix the compiler warnings.
That was a big point. Ignored warnings are just bugs waiting to hatch.
They really are. A clean build is a safe build.
Okay, before we get to the logistics, there's one last tool mentioned, the engineering daybook. This isn't software, it's literally a notebook.
It's an external hard drive for your brain. Memory is so fallible. We think we'll remember why we chose a certain library or how we fixed that weird bug last week. We won't. The daybook is just a running log of what you learned, sketches, ideas.
It also mentions using it to park ideas.
That's crucial for focus. If you're debugging and you get a brilliant idea for a new feature, don't stop debugging. Write the idea in the book, park it, and get back to work. It clears your mind without losing the thought.
Okay, let's shift gears to the nitty-gritty. We have instructions for discussion leaders and some immediate homework deadlines. If you are a student, listen up.
First, the discussion leaders. If you get picked randomly in class, do not just stand there and read a summary. That is not the job.
So what is the job?
The job is leadership. You need to identify the author's point, identify their assumptions, and then drive the group to a consensus. You're trying to answer the question, how do we apply this to our class development shop? You're setting policy.
And you have to document it.
Yes. The leader must update the reading discussion notes page on the wiki. If the decision isn't on the wiki, it's like it never happened. You're building the project's institutional memory.
Okay, now for everyone else. Homework. The notes highlight two major deadlines, Bugzilla and Lab 2. Let's do Bugzilla first.
This ties right back to our talk on professional tools. You need to create your Bugzilla account by Thursday at 5 p.m. Use the link, use your Skidmore email, use your real name.
But, and this is a big but, the notes say, do not add issues yet.
Right. Resist the urge. I know we just talked about how important bug tracking is, but you need to learn the workflow first. There's a walkthrough on Friday. If you start filing junk bugs now, you're just creating noise.
So set up the tool, but wait for the training.
Exactly. It's like buying the saw, but waiting for the safety lesson before you turn it on.
Got it. And the second deadline?
Lab 2 is due Thursday, February 5th. And don't forget that your reading notes for these chapters have to be submitted prior to class to count.
So we've covered the danger of the second system, that arrogant dinosaur building phase, and we've covered the tools that keep you humble: text, shells, version control, honest debugging.
It's a complete ecosystem, really. You need the strategic wisdom to avoid over-engineering, but you also need the tactical skills to build the simple thing correctly.
I want to leave everyone with a thought based on that daybook concept. We talked about how the first system is usually clean because the architect is scared and careful. As you head into the Linux lab this week to work on Lab 2, ask yourself, are you building that first clean system? Or are you already trying to polish a dinosaur?
That is the question. Don't let the ego take over. Keep it simple, keep it text, and use version control.
Start that daybook today. Write down one thing you learned from this deep dive. We will see you in the Linux lab.
See you there.